dugsiga boardingka iyo maalinlaha ah ee Amano Boarding and Day School.
Allah ta'ala wa barakatuh. Alaikum, my students. So welcome to Amano Boarding and Day School. Again, e-learning programs. So we were here, particularly from TOEIS. We were in this chapter, so we have started this chapter. So we took what we call an introduction of acids and bases. But we shall continue using this program, through this program, e-learning program. So our chapter is acids and bases. You see, some of the books may use acids, bases, and salts. Again, some books may use acids and bases. If you remember, most of our school we use a dual curriculum, integrated curriculum. So from TOEIS you are integrated, so you are doing both the mainland specification and Edexcel specification. So we are doing now acids and bases in Edexcel, again in Somaliland specification. So we are doing all. So both the Edexcel and Somaliland specification, they use this term, acids and bases. So in this chapter, we have to classify into three: acids, bases, and salts. So salts are the last. So we have to start acids. For you to learn acids, first of all, we have to know the definition of acids. So we will define acids in different ways. So acids and bases also are divided in different ways in different people. So first of all, acid is divided by someone called it Arrhenius. Again, it's divided another two guys called it Bronsted and Lowry. Lastly, it was divided someone called it Lewis. So start here. So Arrhenius definition. So this is called a traditional definition. Again, all definition. So the term acid comes from where? It came from Latin word which is called acidus. So which means what? It's a salt. So we are familiar this term, or what we call salt taste. You have seen in this one, you have tasted in this one, what we call vinegar, say lemons, and other common acids in food. So that taste. So it came from acidus, or it's a Latin word. Again, it was 1887. A Swedish chemist called it Stefan Arrhenius. This guy was first to describe acids as a substance that produce hydrogen ion. You see, hydrogen ion and hydrogen atom are not the same. Hydrogen ion is not the same as hydrogen atom. Hydrogen ion is not the same as hydrogen atom. Why? Because hydrogen atom, and this is hydrogen ion. It is a positive one. You see, hydrogen atom, it contains single electron and single proton. Without neutron. Hydrogen is the only atom which contains without neutrons. What about hydrogen ion? Hydrogen ion, it contains proton. It contains only proton. It has 0 electron, which means it lost this electron. What about the neutrons? Both of them contain what we call 0 neutrons, or without neutrons. So hydrogen ion is not the same as hydrogen atom, because sometimes we can call this one proton. Because it doesn't have electrons. Again, it doesn't contain what we call neutrons. But hydrogen atom, it contains electron and proton. So this guy called it Arrhenius was first described or defined acid as any substance that produce hydrogen ion rather than hydrogen atom when they dissolve in water. So for example, we have a substance, whether it is organic or inorganic, any kind of substance. If you put in water, then that substance, if it produces a hydrogen ion in water, according to Arrhenius, it is called an acid. Here you have HCl. We don't know HCl whether it's acid or base, but according to Arrhenius, we can add water. When we add water, it ionizes or it decomposes, dissociated into hydrogen ion and chloride ion. So any substance that produces hydrogen ion in water is called acid. So who said that? Someone called it Vicente Arrhenius. So this is the definition of Arrhenius. So how can I summarize Arrhenius definition? Any substance that produce hydrogen ion in water. That's the definition of Arrhenius. That is the definition of Arrhenius. If you consider this one, it is HCl. We don't know HCl whether it is acid or base. But according to Arrhenius, if you put a substance in water and that substance produce hydrogen ion, it's supposed to be acid. It's supposed to be acid. So that's the definition of Arrhenius. That's the definition of Arrhenius. Okay, consider this one. Consider this one. This is slightly different. This is slightly different. You see, here you can see Prolistin and Lowry. Prolistin is a name, Lowry is another name. So they are two different guys. But they agreed one definition. And they defined acid as, you see, in 1923, Prolistin, this guy he was a Danish, the other guy he was a British. So expanded the definition of acids and bases. So they took advantage the definition of Arrhenius, the definition of what we call Arrhenius definition. And Prolistin and Lowry acid donates a proton, what we call hydrogen ion, and hydrogen ion to another substance. So any substance that donate hydrogen ion to another substance, give up hydrogen ion to another substance, is called acid. It's called acid. So they said we don't care. These guys, they don't care water. They don't care water. But here we have a bottle of water. So you know imagination. For example, this part of the bottle, water bottle, it is the substance. But this lid, for example, this lid, it is the hydrogen ion. So I have a substance already contains hydrogen ion, and here I have another substance. So it's a kind of imagination. So we want to explain this kind of definition. So we have two substances. This is substance 1 and this is substance 2. So if a substance produces hydrogen ion to another substance, it's called acid. So who said that? Prolistin and Lowry. So this part is called hydrogen. Imagine it is hydrogen. So this is a substance containing hydrogen, but at that time you can't say this is an acid, because they said what? Acid is any substance that donate hydrogen ion to another substance. At that time you can call acid. So I have substance. Again, I have another substance. So when I combine together, or when I mix together in order to react together, so this substance donates hydrogen ion to another substance. So substance that produces hydrogen ion to another substance is called acid. The other side is called base. Any substance that accepts hydrogen ion or proton from another substance is called base. So we shall see this one. So this is an example. So any substance. Say any substance. When I say any substance, I want to say any chemical substance. So this is a chemical substance. HCl. We have seen the previous example. We have HCl. We want to add water. So HCl contains single hydrogen and single chlorine. When I combine together, hydrogen goes from where? So I have here this hydrogen. Consider this hydrogen. It goes from HCl to here. So it becomes what we call hydronium ion. You see, it was hydrogen ion positive. And it was chloride ion, which is negative. They cancel each other when they are in a compound. But hydrogen and chlorine decompose into hydrogen ion and chloride ion. So this hydrogen ion goes to the H2O. So this H2O, it already contains two hydrogens and one oxygen. When you combine another hydrogen, it will become H3. Rather than it will become H3O. And you want to mention the plus, the positive ion, because the hydrogen come from the hydrogen chloride, it was positive 1. So it is hydronium ion. So any substance that produce hydrogen ion, that donate hydrogen ion to another substance, is called acid. So this is acid. The other substance which accept hydrogen ion from another substance, it is called base. So we shall see this one. We shall see this one. So this is the definition of what? Bronsted and Lowry. So they divided acid as proton donor, proton producer. So let us come to this point again. So we said what? We divided acid in two different ways. First one, Arrhenius divided acid and substance that produce hydrogen ion when they dissolve this in water. The other two guys, they agreed one definition and they said any substance that produce hydrogen ion proton donor to another substance. This is the last definition. It is called Lewis definition. This guy is called Gilbert Lewis. So Gilbert Lewis focusing on the donation of what? Or acceptance of pair of electrons. So donation and acceptance is different, but Lewis acid, we want to focus on Lewis acid rather than saying Lewis base. So Lewis acid is electron pair acceptor. So this is very simple. This guy he's focusing on other side of electrons rather than proton or hydrogen ion. Then he said any substance that accepts a pair of electrons is called that accept a pair of electrons is called acid. Here I have what? Boron trichloride, and here I have fluoride, Consider here. Again, I want to choose this blue one. Boron trichloride. This boron, the central atom contains only 6 electrons. Here it has 6 electrons. So I want to choose here again this blue. Yes. So this boron, it has 1 electron from boron. It contains 6 electrons. You see, this is fluoride ion. This fluoride ion, it contains 8 electrons. You see, if you remember, fluorine is group 7. That's fluorine atom. One fluorine accepts another electron from another substance, it should become 8 electrons, which means it has extra electron. So this fluorine, it has extra electron. So I can't call fluorine, it is called fluoride ion. So fluoride ion will react with boron. You see, this boron, the central atom should be 8, but at this time it's not 8, it has a 6. This here you have a single bond. So each single bond contains 2 electrons. So if you count 2, 6, and it requires what? 8. So this is not full. But fluoride ion, it has an extra electron. So fluoride ion and boron trifluoride will react together. When they react together, the kind of reaction is a covalent. So they should share electrons. So at this time, boron, it doesn't have electrons to share with fluorine. And fluorine, it has extra electrons. So in here, both electrons, you see, they should share electrons. When they share electron, these 2 atoms, one should come from boron, the other one should come from fluorine. But if you consider this one, boron is group 3, it has 2 electrons, you don't really share it with another 3 fluorines. At this time, it can't share electron. It has a 0 electrons. What about fluorine? Fluorine, it has extra electrons. So this fluorine, it contains so many electrons. It is an electron-rich molecule, and this is what we call electron-poor molecule. So they want to combine together. So how do they do this kind of reaction? This fluorine donate both electrons. It should donate both electrons. So here is a bond. This kind of bond is called coordinate covalent bond. Why are we calling coordinate covalent bond or dative covalent bond? Both sharing electrons are donated by 1 atom. So who is that atom? It is a fluoride ion. So one fluorine donates 2 electrons to boron. Boron should accept. Consider here, boron, you see the electron is from where? From fluoride to boron. So boron should accept 2 electrons. Any substance that accepts a pair of electrons is called Lewis acid. What about the another species which donates a pair of electrons? It's supposed to be base. So that base we shall see. But in here, Boron, it doesn't have electrons, so it accepts 2 electrons from fluoride ion. So any substance that accepts a pair of electrons from another substance is called what? Acid. So this is called Lewis acid. So we have 3 different definitions. First one is called Arrhenius definition. Second one is called Bronsted and Lowry definition. Lastly is called Lewis definition. Okay, so let us come to. So these are the definitions. What about the properties? You see, acids should have a common property. So we want to do various properties of acids. Say common acids, strong and weak acids. We shall see that. So we want to finish ferrous acids. Again, we will start basis. Lastly, we shall see what we call salts. So the properties of acids. You see, acids should have what we call sour taste. You see the taste of this lemon juice, this lemon. So I think you are familiar with the taste of this one. So that kind of taste is called what? Sour taste. What about less than 7 on pH? We shall see pH scale. So it is a scale. There is a scale in between 0 up to 14. The middle one is what we call 7. So any number pH scale, any number below 7 is called acid. What about above 7? It's supposed to be base. This 7 is the neutral point. You see, acids form hydrogen ion. Or they contain hydrogen ion. So most of the acids should contain hydrogen ion. Most of the acid. So we're using the definition of what we call Arrhenius and Bronsted and Lowry. But some of the acids does not contain hydrogen ion. If we use what we call Lewis definition. So most of them, they contain hydrogen ions. It's a kind of property. When mixing with base, acids mixing with base, if you combine acid with base, they neutralize each other. And they produce what we call salt and water. For example, you have an acid. If you add with a base, then acids and base should produce salt and water, which are neutral substances. Most of the acids conduct electricity. Can conduct electricity because they contain 3 ions, hydrogen ions and other anions. That's why they can conduct electricity. They can conduct electricity. We can say they are most of acids are soluble in water. They are polar solvents. We can add these things. So include what? Orange juice, lemon juice, Pepsi, Coke, and vinegar. So these substances are always acids, and they have these properties. Here we have a table. So this table names of common acids and their anions. Anion is there, negative ion or negative ions. It can be polyatomic anion or non-atomic anion. So here we have acids. These acids without oxygen. Some of the acids doesn't contain oxygen. Some of the acids contain oxygen. So those containing without oxygen, like what we call halides, hydrogen chloride and hydrogen bromide. When you add with water or in aqueous solution, these are called hydrochloric acid, hydrobromic acid. If it is iodine, hydroiodic acid, hydrofluoric acid. So these are 2 examples. So they contain an ion. The negative ion is what? Chloride ion, and this is what? Bromide ion. Where is the positive ion? The positive ion should be hydrogen ion. So name the ion. It is called chloride. This is called bromide. Here I have acids with oxygen. These are the name metals. For example, acid number 1, it contains nitrogen. Acid number 3, it contains sulfur. Some contain carbon, phosphorus, and chlorine. So consider. So my student is, you can read. For example, HNO3, this is called nitric acid. So the anion is what? Nitrate. For example, this is called what? Chloric acid, and it contains ClO3, which is chlorine. So I want to summarize my lesson here. Thank you, my students.